Hey guys, so what we want to know in this first few questions, I'm actually going to go through 3, 5, and 7, kind of talk about the descriptions here, some things that we have to look for when we're looking for whether something's a polynomial or not. The things that we are typically looking for in a polynomial, okay, x can be in the problem multiple times, but it has to keep a positive exponent, okay, and it has to be a whole number exponent. So, if you look at this first problem, looking at the only x in the problem, does that look like a positive whole number? The answer is yes. So this would be a polynomial. So we would want to write it in what's called descending order. Biggest exponent down to our constant. So this should actually be written as negative x squared plus 8. The degree is the biggest exponent, which is 2. Okay? And the leading coefficient, the LC, is the number in front of that term, which would be negative 1. That's how question number 3 should be answered. Question number 5. The square root of 6 is just a number. So the only thing we're really looking at is the exponents on the x. This is a 4. That tells me this is a polynomial. Because this is the only x in the problem, this is already in descending order. So now what I need to do is I need to determine what the degree is, the degree, and the leading coefficient. The degree is the biggest exponent, which in this case is 4. The leading coefficient is the number in front of that x term, which is pi. It might seem funny for pi to be the number that we're talking about, but it's just a number. This last one here, we can see that we have x to the third, and we have x to the first. Okay? So we got a 3 and we got a 1. This is already in order, so third, then we're missing our x squared, but if it's not there, it's not there. As long as we're not adding something else in, we're good there, and then a negative 10. So it's already in order. My degree is my biggest exponent, which should be 3, and my leading coefficient is the number in front of that term, which is negative 5 over 2. Again, we're just looking for the number in front and the biggest exponent. And we use that information later in the homework to be able to determine how graphs would look. So, whoops, we want to go there. Okay, let's try that again. Erase and erase. There we go. Come on, Mr. Welch, get it together. All right. So from here, we're going to go down and we're going to talk about our direct substitution versus our synthetic substitution. Okay, so let's take example for, we'll do question number 9. Get the calculator pulled up here. Let's just look at number 9. It has 5x cubed minus 2x squared plus 10x minus 15. I'm going to just use my calculator, and I'm going to type it in all at once. It's 5 parentheses. My x is supposed to be a negative 1. I'll get you out of the way. There we go. Negative 1. Okay, but that's got to be raised. That's this key right here to the third. And then we got to get out of the exponent, minus 2 parentheses, negative 1, close parentheses, squared. That one I can do with just a square button. And then we got minus 8x, minus 8 parentheses, negative 1, and then minus 15. Whoa, I skipped down a line. You guys, I almost blew it. Let's come back here. This is supposed to be plus 10. Jeez, Mr. Welch. Let's go plus 10. Sorry, messed that up pretty bad. Plus 10 times negative 1, and then minus 15. Got to be careful when you're reading out of the book. Come up with negative 32. My answer is negative 32. Done. Now, the place where we really want to get to is where we're doing synthetic substitution. Let's take a look at question number 16, and then we'll also look at 22. Actually, we're going to just jump down and do 22. It has a little bit of a hiccup, and that will cover all our bases if we just take care of it now. So first thing is our bouncer is whatever we want x to equal, which is 4. And then our numbers across the top. This x to the 4th needs a number in front of it, so we're going to put a 1. So that's 1x to the 4th. Okay. The next term should be x to the third, but I don't have an x to the third term in this equation, so I have to put a 0. The term after that should be x squared, but I don't have an x squared, so I'm also going to put a 0 there. Anytime a number is missing, a term is missing from the polynomial, synthetic substitution requires that we use a 0 to placehold. And then we have 3x, so for the x term, right, it's 3. And then for my constant, it's negative 20. And underneath the constant is where the box with our solution always goes. Now keep in mind, you don't have to write x to the fourth through x to the third up. We don't have to write these up here. I'm writing them so I can explain why I'm putting the zeros in there. All right, first number drops down 1. To get back in, I always times by the bouncer, so 4 times 1 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. 3 plus 64 is 67. 4 times 67, I think it's 268. We're going to check that real quick. Nice thing is we can do this with our calculator along the way. It's actually very, very handy. Let me show you what I mean. I would start with the 1, and then I would times it by 4. Then I would add 0, and I would times it by 4. Add 0 times by 4. That gets me to the 64 plus 3 times by 4, 268 plus a negative 20. 248. Now you already knew that, but still, if you want to use your calculator to help along the way, it's just a button at a time. So that's how we do the synthetic substitution. Comes up with the answer. If you'd done 4 plugged into this equation originally, same answer. Doesn't change anything. Oops, forgot. I got to get my right pad here. Let's get rid of all that. And then the last thing that we're going to talk about is how do we know which way the arrows point in a polynomial? This last part of our homework, if we look at, let's just grab number 33. It's as good as any. Okay, so number 33, our job is to figure out where the left arrow and right arrows point. Okay, so I know my answer is going to look like this. I just need arrows on the 2 lines. So the 2 things I look for are the degree and the leading coefficient. The leading coefficient is the first thing that I actually want to find. And it is the number in front of the biggest exponents in x. So there's my big exponent of 5. That'd be my degree. My leading coefficient is the number in front of that, which is negative 6. If the leading coefficient is negative, the right-hand side should point down because it's negative. So I'm going down on the right. That tells me that this arrow is down. Okay. Then the degree is going to tell me if the right side and left side match or not. Because the degree is odd, my arrows will oppose each other or be the opposites. So because my right arrow is down, my left arrow must be up. Okay? It's really important that you learn to do this from right to left. If you try to put the left arrow in first, it's going to mess you up. Okay, so start with that right arrow. Which way is it pointing? And then just figure out, is the left arrow agreeing or disagreeing? That's it. Hopefully that makes a lot of sense to you. If it doesn't, shoot me a message or come see me before or after school. Good luck.